Hi, I'm Amir Hossein Mirzabozorg, and in this video I want to talk about Abaqus Warning. Elements are distorted and the mesh quality is not appropriate. How to ask your video related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We try to answer all questions regarding the video details in the comments below. This is the table of content. I will talk about problem description, a special mesh pattern of the billet, Abaqus warning, elements are distorted and the mesh quality is not appropriate, effect of the low quality elements on the simulation, finding the low quality elements mentioned in the warning, main reasons of low quality elements, effect of low quality elements on the stable time increment size, use of mass scale to increase the time increment size in the quasi-static problems. And finally, next tutorial content. The simulation procedure starts after job submission. You would probably receive warnings in the job monitor dialog box during the simulation. Generally, warnings depend on the settings of the model in each of the Abaqus CAE modules or attached subroutines. This tutorial focuses on one of the most common warnings of the Abaqus and gives you deep insight into the procedure of encountering and troubleshooting it. Now I want to talk about problem description. Reverse extrusion is modeled in the axisymmetric space using the Abaqus explicit solver. The model consists of the punch, die, and billet. Punch and die are modeled as analytical rigid parts. Die is fixed and the punch moves downward to form the billet to a thin hollow cylinder. To conduct the simulation using the ALE method, a special pattern of the mesh must be defined to avoid the excessive distortion or zero or negative mass errors. To define the mentioned mesh pattern, the billet must be partitioned. And this is the special mesh pattern of the billet. Now I want to talk about the warning. While running the model, this warning has been received. This warning says that a number of generated elements have low quality. Now I read the warning. 202 elements are distorted. Either the isoparametric angles are out of the suggested limits or the triangular or tetrahedral quality measure is bad. The elements have been identified in element set 1, LM distorted. The number of distorted elements depends on the mesh and it depends on the simulation. Now I want to talk about effect of the low quality elements on the simulation. When we are using Abaqus standard solver, low quality elements can lead to convergence issues or decrease in the accuracy of the simulation. Convergence issues can lead to error. And when we are using Abaqus explicit solver, low quality elements can lead to error or decrease in the time increment size or decrease in the accuracy of the simulation. Now I want to talk about finding the low quality elements mentioned in the warning. At the start of the simulation, low quality elements can be found via the display group tool. After submitting the job and after receiving the warning, we can go to visualization module and use display group option and then find the low quality elements. We must select elements from the item and element sets from the method, and we must activate highlight items in viewport. Now I want to go to Abaqus to show you how to do this. This is the billet. This is the die. and this is the punch. I have defined density and elastic behavior and plastic behavior for the billet. This is the assembly. I have defined a dynamic explicit step. NLGM is set to on, time period is equal to 1, and I have defined mass scaling factor, and the factor is equal to 100. I have defined two surface-to-surface contacts. The first one is defined between the punch and billet, and the second one is defined between the die and billet. And I have defined ALE adaptive mesh domain. I have defined three boundary conditions. The first one is defined for the billet. The second one is defined for fixing the die. And the third one is defined to move the punch downward. And this is the mesh of the model. And this is the warning. I click on display group. I select elements, element sets, and I select one element distorted, and I activate highlight items in viewport. And you can see that these elements are highlighted. These elements have low quality. Now I want to talk about main reasons of low quality elements. Low quality elements can have two main reasons. The first one is defining a special mesh pattern, such as the simulation of the reverse extrusion or Roberts compression. In this case, there is no need for modifying the low quality elements because the mesh pattern is important. In the second reason, the geometry is complex or an appropriate meshing strategy is not used, including the selection of element size, element shape, meshing technique, partitioning, and virtual topology. In this case, meshing strategy must be modified in order to decrease the number of low-quality elements. Now I want to talk about effect of low-quality elements on the stable time increment size. In the mesh module, by using the verify mesh tool, we can find the elements with a small time increment size. And as you can see, similar elements are highlighted. These elements are highlighted in the visualization module, and these elements are highlighted in the mesh module, and you can see that they have similar elements. Now I want to go to Abaqus to show you how to do this. I go back to the mesh module. I have activated a stable time increment less than, and I have entered 10 to the power of minus 7. These elements have the stable time increment less than 10 to the power of minus 7, and the smallest stable time increment is equal to this value. The stable time increment size can be increased by defining the mass scale factor in the step module. In the step module, I have defined mass scale factor equal to 100, and as you can see, the smallest stable time increment size is increased. The mass scaling factor is equal to 100. In the following tutorials, you will learn the procedure of resolving or encountering other warnings of the Abaqus. You can contact me by using Telegram or WhatsApp, or you can send email to me. We can have one-on-one tutoring on the AnyDesk, WhatsApp, and we can make special tutorials to your order. We can conduct high-quality simulations for your thesis, exercises, and industrial projects. Finally, I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.